Hello, Internet, and welcome to Unity Theory, except that's not the name of this channel. My name is Sebastian King, and next to me is my glorious partner. What is your name, sir?
My name is Malong and I. I'm a partner of Sebastian King.
Yes,
Sebastian King.
that is me. Don't go saying my name twice. Say it thrice.
Sebastian King.
There you go. So this is our Lab 6 update video. So what we decided to propose for Lab 6 is that we wanted to create a 3D platformer game with a similar gravitational system to Mario Galaxy. So in Mario Galaxy, you have different types of planetoids. They could be spheres, they could be cubes, they could be disks, capsules, whatever you want. And you can walk on them as if they were planets. And we wanted to make a system that was similar to that. So the first thing that we're going to be showing off here is our player controller. Right now, this is just being shown on a normal plane. And if we go ahead and click play, we can see after Unity decides to compile it, that we can rotate our camera 360 degrees, and we can move in 4 directions. We can strafe left and right. We can move forward and back. Direction we base off of the forward direction of the camera. So this is just me holding down W right now. Let's go ahead and actually look at the code for that real quick. So let's go ahead and unpause that. Let's go over to our scripts. Here we are. All right. And if we go to our player controller, at the top, we've got a good few different fields. Some fields for things like movement speed, for our falling speed, our rotation speed, and we'll get to what some of those things do here in just a second when we talk about the planetoids. We're getting our inputs from our input manager, which is just declaring our input instance. We're using vector 2 for that. And then we're mapping the inputs X and Y to the forward direction of our player. And then we pass that inside of fixed update, where we multiply it by fixed time and the speed. Because you always want to do your movement inside of fixed update, your physics movement. And then inside of our move, we're using a method called smooth damp, and smooth damp will take our current velocity and then it will smooth it to the new velocity that we want to give it, so that it can simulate acceleration. And then we simply set our velocity equal to that movement. And then we have some other methods here for auto orientation to planets, and for checking if we're grounded, for when we're jumping. And we'll get more into that as we talk about the planetoids. And I'll hand it over to you, Malong.
Yeah, so that was Sebastian's awesome player controller. So what we're going to use the player controller for, and this is the more tricky part, is I meant to change scene. So we have these planetoids, and like Sebastian said, we want it to be like Mario Galaxy in the sense that player objects and other things like enemies will realistically be attracted to the faces of these weirdly shaped planetoids. So a very simple case is a sphere, where it's just like our planet Earth. Gravity goes in all directions around the sphere. But for something like a capsule, now we have a little harder case here. So we want to focus on making it behave like a spherical gravity field for these two parts on the sides. But for the cylinder in the middle, we want it to go straight down and straight up. So in the code, essentially what these planetoids are doing right now is they are finding all of the attractees, we call it, which include the players and enemies, within a defined range. And for each attractee in the range, we want to attract it or apply a force on it that follows a gravitational field. And as a simple demonstration, we can see this play out in action for the capsule planetoid. So the player here should be attracted to this side of the sphere when he's on this side of the capsule. If he's in the center portion, then he should be falling straight down. And the reason he didn't fall straight down there is because he had a little velocity attached to him. But if I just grab him here and take him back down, as you can see, he falls straight down. And if I go to the right side of the capsule, he will fall towards that face of the capsule. And so what's going on here is that simply to find the attractees in range, we just use physics.overlap. We look for the attractee layer. And meanwhile, when we actually attract the rigid body, what we're doing is, in essence, calculating a direction vector from the player to the planetoid. And that direction vector depends on which part of the capsule the player's in. So we define these lower X and upper X bounds that essentially divide this thing up into 3 parts. And then in those 3 parts, we know if the player's in one part or the other. And based on that, we have a focal point defined where the gravity vector is simply from the player to the focal point. So in the sphere case, which is simple, the focal point is simply the center of the sphere. Okay, and the force magnitude, we follow Newton's law of gravitation, which is mass times mass over distance, or we could follow the gravity constant, which is 9.8 meters per second squared. Cool. So that was the capsule planetoid, and the reason I showed you that more complicated over the sphere is because right now in the sphere we're experimenting with how the player interacts with the sphere. So one challenge that we're facing right now is, while the player can move around and be affected by gravity as we want it right now, the question is, when the player moves around using WASD, the player's sphere also has to rotate such that he is moving in a direction that is tangent to the sphere. In other words, if we don't change the rotation of the player, then the player will just fly this way off of the sphere. He'll go flat. But what we want him to do is to rotate with the sphere as he's going down. And so that goes back to the auto rotate function that Sebastian was talking about. Sorry, auto orient, where essentially we need a down vector that tells us which way is down towards the planetoid. And from that, how do we orient ourselves so that we are tangent to the surface? So in the sphere planetoid here, it's very simple in terms of the direction. It's just from the attractee to the center of the sphere is the direction. But the more interesting thing here is that we auto-orient it using that direction of gravity. And what that should do, and fortunately it's working right now, is it should affect the forward direction of the player such that it's tangent to the sphere. So we can see this in action here, where first the player falls down from gravity onto the surface. Yep, and then we can move the player around, but pay attention to the blue vector you see. So that's the player's local forward. And as we can see, when he's moving forward with the sphere, that forward vector is also moving or also rotating with the planetoid. So this is what we want. And the challenging thing that we have moving forward is how we can apply this to the different types of planetoids besides the sphere. Okay, so that brings us into our to-do list here.
Yep.
So
on our to-do list, the next type of planetoid that we're thinking of making is the cube planetoid, which we are already in the process of developing right now. We're going to make some simple enemies and collectibles and a win condition to make our game feel more like a game, give it some game conditions to it. We're going to go through some UI, and then time permitting, one of the bonus things that we want to add is that there are different types of gravitational fields in Mario Galaxy besides just these ones. So you may be able to, walk up walls or kind of walk on wedges and stuff like that. And there are fields that simulate you smoothly moving between different surfaces like that. So if we have time, making gravitational fields for those type of surfaces would be something that we want to do.
yes. And as we stated in our proposal, this is a tech demo first and a game second. So by next Wednesday, when this is due, we hope to have all of our planetoid gravity working for the fundamental planetoids, yes. Not the bonus ones that we're talking about before. And hopefully we can get to these more gamey aspects and make it into a game.
Yeah, exactly. And I think that should be everything for the update video.
Yep. I don't have anything either.
All right. Well, if that's that should be the end of the video then. So if you're new, go ahead and smash that like button. Go ahead and
Be sure to subscribe, turn on notifications, share it with your friends, share it on Twitter, Facebook, blah, 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 blah. Oh yeah. Twitter's in a bad state.
not Twitter, but Instagram. Sure, why not?
Yeah. And yeah, thank you for watching.